All right, everyone, now we've talked about Teams and what it can do from the client side. There's actually one additional thing that it can do. We're going to talk more about the networking side as well as the enterprise voice functionality. What the heck is that? Well, we're going to get to that. But first, let's start talking about the actual network. How does this work? How does Microsoft have this all set up? Well, Microsoft has set up what they call the global network. Now, this picture here is essentially all of the data centers that exist throughout the world and how they are essentially all connected to each other. As you see here, we are very much a global network. And the idea here is that we want to be able to have our device connect to, again, wherever it may be. It's going to connect directly to the internet to what Microsoft calls a front door. Now you'll notice on here all of these are all front doors that exist here. There's all over the place. These are all places that I could connect to inside of, to get to my Office 365. Now once I'm actually connected to my front door there, I'm going to be taken through Microsoft's backend network, which we measure in terms of speeds as petabits. Okay, so that's above terabits. So we're looking at petabits per second in terms of speed that can go back and forth between their data centers. Very fast we're talking. So our job is to get our client to connect up to the internet as quickly as possible in the least amount of hops. And we're going to talk about that here. But again, the idea is we want to get there as quickly as possible. Now, what some problems with that? And this is one of the biggest problems that I had with my customers in the beginning of when we had everything locked down and during the pandemic, where everybody wanted to essentially redirect traffic from their device through a VPN link through the data center and from the data center out to the internet. Now you can imagine that is quite a a route, we'll just say. It's quite a route that it goes. Okay, so it is going really, really far over that. Round trip time is something that we really need to look at. But before we do, why don't we dive into here a little bit more detailed of how our client will connect. So let's give you just a little bit of this is a Microsoft one, and I'm just move myself just a smidge down. That no matter where we are over here on the left, so we could be our central office, we could be at our central office, we could be at a branch office, or we could literally be anywhere else. That's what this one here is. Literally anywhere else. Airport, hotel, coffee shop, home, whatever. Okay? So in this instance here, we are trying to get as fast as we can from this location to here, which is all these front doors. And this is the intermediate location, which is the internet. So we got to be able to get up to the internet as quickly as possible so we can get Microsoft's global network and their backend to get to Teams, Exchange, SharePoint, whatever it is. We're trying to hit these regional front doors. So in this instance here, when we are doing, let's just say for our central office, we're just in a computer that's over here. It's going to essentially hit our firewall, which is going to take us to the internet, which is going to take us to the front door. Now, this can be a good thing or may not be a good thing. So here's one of the things, and we see this little word right there that says proxy. That could be a good thing or may not be a good thing. So proxy essentially takes traffic and inspects it as it's going through back and forth as bidirectionally, and it's inspecting that traffic for malicious things and bad things. Okay, so in this instance here, we got to really look at it as like, okay, well, remember we're trying to get there as quickly as possible. So if I'm breaking traffic and I'm inspecting it, that takes time, right? That's going to increase my round trip time. And what happens if we don't? Well, we'll get to that here in the next section. But I want to say here is that if we increase the time through proxies and such, and we are routing all over the place, we got some problems that we have to look at. So again, here's our central office with the internet service provider with the pipe that goes directly out to the internet. Now, traditionally, we always want to whitelist Microsoft endpoints from proxies and scans and all of those, but I'll get to some best practices here in time. So we are in a branch office, let's just say. Now, a branch office could be a small little office that is probably, it doesn't make sense to have its own internet service provider. So what we do here is we have a WAN link between the two. And you can see we have a WAN device that are essentially just connecting. It's just, like a little bridge, if you will, that are connecting between these two locations. So all our traffic is coming from the branch office to here, which is then coming back out through this main pipe. Now, that's okay, and that's not really that big of a problem because these little devices here are designed to handle it, and the people that are over here are probably a pretty small number of them for us to be able to have some sort of backbone between the two. And so we'll kind of go out this way. Now, obviously, if we're starting to get to the point where this branch office is pretty big and we have a large number of people, then it probably makes sense that we have essentially a mirror of what we have over here that goes as its own dedicated internet service line out to the internet as well. So we can go directly from the branch office out to the internet. So it depends how many people are over here. I generally say, I mean, if we're looking at 25 to 50, that should be okay. But anything beyond that, we need to start looking at its own dedicated pipe. Now, again, prior to 2020 here, this is essentially the way most, I would say 99% of networks worked. However, now we have to incorporate this third place here where people could be working literally from anywhere. And they will have their own local ISP. So you have your own internet provider that goes out to the internet, obviously. So we just come from our home to one of these regional front doors. And we got to get there as quickly as possible. And that's cool. But what about in the instance of, as I said before, when we're at home and the only way that we want to be able to do it is to VPN? Well, what we have to do here is come through our internet service provider, through the virtual WAN link, which would be a virtual network, the VPN network, come over here, backhaul through our central office. Now, let's just say in our central office here, we would have, let's just say this is in Houston, Texas, and I'm over here in Seattle, Washington. You know, I got to go all the way across the country, take my traffic, go all the way across the country, and go through the area over here. Now, here's the funny part is that, remember, these are regional front doors. So there exist several here in the United States. And we always want to go to the most geographically relative to us. And I'll get to that in time, but we obviously want to go to the one that is most close to us. So in that instance there, if I got to come all the way back and go all the way out, I'm going all over the world just to literally try to connect to the internet in one of these front doors. So what we do here is we use something called split tunnel VPN. So in this instance here, if I'm trying to get to my office resources, I will use a VPN link that comes all the way over here to my central office, and I get whatever I need to over there. Those could be file shares. They could be, you know, like a ERP, or there could be a document management system or something over here in the central office that I work with frequently. And then I will have it where we are splitting the traffic for destined for Office 365, and that goes directly out to the internet. So it'll be right here, and it goes directly out. So we hit our front door quicker. Now, again, this is just an example here of it, but this is just a high-level overview of essentially how a simple network works and most organizations work. Now, the big question is, well, why the heck do we care? Well, if it takes longer, well, what's the problem? Well, especially when we're dealing with Teams and we're dealing with something called RTC, which is real-time communication traffic, we have to talk about call quality experience. This is a big deal here. This is that if our audio quality is terrible, you know, and we're trying to make a phone call and it's taking forever for it to go and the quality is really garbled and it's just slow and it's clunky and you can't understand what the person's saying on the other end, why even have a call? That's the whole purpose of this. Why have a call at all? So we want to be able to get to it as quickly as we can. The reason why that we care about the quality experience, because if the user has a poor quality experience, the entire experience is poor. If I can't have a good call and I can't understand what they're saying on the calls, even on meetings, it's the same exact thing. Meetings are calls too, but if the meeting itself is a poor quality, how can I collaborate with people? How can I meet with people and communicate with people here? So this is where things start breaking down when we have poor quality experiences. Traditionally, if we are coming from the network, it is optimized traffic and we can get there quickly. But now, again, the problem is when people are starting to come from their home, well, what do? Well, we don't need to backhaul any of that data. We don't want to. And that's actually brings into the next point here is what are some good practices for the best quality? So one of the first ones that I always talk about here are quality of service markers. So these are QS markers or DSCP markers. So we prioritize traffic. Okay, so in voice traffic, we are really looking at UDP type traffic here, okay, so user datagram protocol. So when we're talking about that, what we're doing here is this traffic here is packetless. It is just being sent out and blasted out, and we don't really care if it reaches on the other end because we just want to get the traffic out there as quickly as possible so we can get it on the other end. But if we have problems in between there and we lose a bunch of packets, we start losing call quality. Okay, so again, once we start having that round trip time or the jitter in between the lines and everything, or running into some problems there, the longer it takes, the more quality experience, the least quality experience we're going to have. So in this instance here, round trip time is essential, because what we're doing here is we're going to take that and prioritize that UDP traffic. So we can tag it from the device and says, this is priority traffic. And as it's jumping through the network, we can honor that. So it makes sure that it hits every destination or every hop that it needs to hit. So it gets to the end, wherever that is, and that's normally in Microsoft's data centers. Once it gets to it there, it will say, okay, well, we're going to continue prioritizing this traffic. Microsoft will honor the DSCP markings. So at that point there is that we're going to increase that quality. We're going to have very good quality experience for the users. So a phone call will be very similar. When we're having a Teams call, it's going to be high band audio. We're going to have good experience. Same thing with the video. It's not going to be choppy or laggy or anything like that, or screen shares. Any of that media traffic there is really going to fit into these categories. So quality of service markers, these are very good practices to do. Now, I'll be honest, it does take some time and effort, because you do have to set up your network to be able to accept this. And most people at home, you can't prioritize your network. Our devices here inside of a home network is nowhere near the enterprise-grade equipment. Another thing that we can do here, situational awareness and training. So this is really around Wi-Fi, but also the devices, which I'll get to here too, but situational awareness. So one of the things that we see a lot here, and I'm working with a company right now, they're very old school in their manner. And they just refuse to use a locally attached device from their computer, like a headset or a speaker, or literally anything. They refuse to use those. So every time they jump into a Teams call, they dial in through the PSTN, or the Public Switch Telephone Network. So they're basically calling in. Well, the problem with calling in, it's fine and it works, but the problem with calling in is it's terrible quality. I mean, we're talking about a phone network that is, 100 years old? So the problem that we run into is that your quality is generally pretty bad. You don't get all of the noise suppression functionalities. You don't get the wideband audio. You don't get the ability to mute and unmute with the smart buttons. That's where Microsoft is starting to get towards, and they really want you to really utilize some of the more Teams certified devices, but I'll get to that in time. But the other thing comes into play here is that situational awareness. I'm on a call, okay, and I'm using my Apple AirBuds, let's just say. I'm not going to have as good of an experience as if I were to use a Teams certified device, but that's okay. I'm not expecting anything major, but think about it from the perspective of the user is that, hey, I'm on Wi-Fi. Well, if I can, let's plug in. Wi-Fi typically is going to have a little bit less, and we all have seen that, I'm sure. The difference between plugging in a device versus Wi-Fi is, it's pretty big. Nowadays, Wi-Fi is good, sure, but when we're talking about real-time communication traffic, we want to be as best as we can. So we say that, hey, if possible, if you want the best quality experience here, don't take your computer and go on the dead spot of your house and expect to have a good call. Take it there and plug it in if you can. So again, just situational awareness and training. That's really what it comes down to. What's going to give us the best experience. All right, avoid proxies and firewall inspection at any level. Okay, so here's something that we have to really, this is the elephant in the room here. So again, remember, we've spent millions of dollars potentially on blue coats or on, Palo Alto firewalls and all of these proxies and everything that inspects traffic. Remember, round trip time is the most important, and we're taking time to inspect that traffic as it's going in and out of my organization. Well, is that really useful time? Well, no, it's not, because it's going to increase the round trip time and it's going to decrease the call quality. So what do we do with these here? Microsoft's recommendation is to bypass proxies and firewall inspection. And the reason being is for quality experience. Now, keep in mind that this is all end-to-end encrypted. Okay, so this is using port 443, especially when we're doing our signaling. Signaling traffic here is all going to be secure. It is end-to-end encrypted. Okay, when we're having these conversations, it can't just be intercepted. It's not that easy to do. You can't just be like, oh, I'm going to intercept this. We're not sending out clear conversations over the internet, of course. So what do we do here? Well, Microsoft wants you to avoid it. Microsoft wants you to whitelist the URLs and IP addresses that they have that also basically say, here's the locations and here's where here's our endpoints, and we want you to whitelist all traffic destined and from those locations. So at that point there, that's just another way of increasing, or I guess decreasing, the round trip time. Use geographically local DNS recursion. Do not use 8.8.8.8. This happens all the time. And what I normally see is that when we set up, when you're looking at DNS and we're doing DNS forwarding, a lot of my customers will use 8.8.8.8 as a DNS forwarder. Well, the problem with that is that could be anywhere in Google. That's Google's DNS resolution service, and that could be anything. So you could be getting IP addresses for a front door, a Microsoft front door, that's maybe you're in Seattle, and you could be getting one for Virginia, which that could happen, but I'm going all the way across the country just to reach it there, because that's what it's giving us, because that's what it is looking at with 8.8.8.8. What Microsoft wants you to do is use local DNS recursion and local internet service providers. So if you are forwarding your DNS requests to your internet service provider, you're going to get geographically relevant DNS results. Okay, so if I am in Seattle and I look up where my internet service provider, which is going to be out of Seattle, it's going to give me IP addresses that are geographically relevant. So it's going to say, here's your Seattle front door, and it's going to connect to it, and then you're going to connect to it as quickly as possible. You don't have to go across the country. So Microsoft wants you to use the internet service provider for DNS recursion. Now at home, for a normal user at home, this is not really that big of a deal. But the problem is that if we are potentially modifying DNS recursion through group policy or something, and it's got to go over the VPN link and everything, that's where we run into problems. We don't want to do that. We want the computer to essentially go and connect to the internet and get to the front door as quickly as possible. Last piece here, use Teams certified devices, or one of the last pieces, excuse me. Use Teams certified devices. So as I said before, it's not really good practice anymore to call in to a phone or to a conference or to a meeting. It's just really not. It's actually kind of tacky nowadays. Again, this is my personal opinion. I just think it's kind of tacky to call in and dial in. They have their use. Don't get me wrong. Dial in is that, okay, my internet's down or whatever, but I still need to get on this call. Or maybe I'm taking it from the road. That's fine, and that makes sense. Maybe we want to do hands-free or something like that. Okay, sure, that's fine. But when we're looking at it and we're sitting at desks and everything, why on earth are we using we'll say a many decade old network to connect for voice? We want wideband audio. We want device buttons. We want those smart buttons. We want noise cancellation. We want because Microsoft or Teams has built-in noise cancellation inside of software noise cancellation. So it detects when people are, there's a lot of noise going on or whatever, or non-speaking we'll say non-speaking sounds, and it actually can filter them out. We don't get all of that when we dial in from a phone. We don't get all these great features here. So you want the best quality experiences? Well, don't use dial-in conferencing. Now again, it is available and it certainly has its use case scenarios, but for the most part, dial-in conferencing is going to be a lesser quality experience. So with that being said, why don't we start looking at the next concept here. We talked about the global network. We talked about good practices. Okay. But when we talk about Teams Enterprise Voice, this is a big deal. Okay. So we've talked about how much Teams can work. And this is actually around the idea of soft phones. This is a software phone. Okay. So, before we would have a desk phone that would sit on our desk and we would have to pick it up and, it would be a physical device. Well, that doesn't necessarily need to be done anymore. Now we have a Teams phone that is directly tied into our client. We can have a dial-out number. We can have a dial-in number, of course. We can have people call us. We can call them. And we can go directly through that PSTN calling. So again, if I actually need to call people, I can do that. I can make and receive calls from the public switch telephone network. So I can jump in and I can actually call somebody's cell phone, or they can call me, or if I'm away from my desk, I can forward it to my cell phone, whatever I want to do. And that's the cool part about it here is because we can take this, integrate it into the soft client, we can dial it directly, we can use our little device that we have. I am a big fan. I don't really like over-the-ear devices. I'm more of a fan of I call them hockey pucks, but essentially, we have lots of different types of them, of course. But I like using those. I just think they're easier, especially when you talk for 12 hours a day with various customers. It's much easier to be able to not have something over your ears and kind of pinching your head all day. So I use that very frequently. But I also, and I do have one here right next to me, which is a desk phone for Teams. So you do have the ability to have a desk phone if you wish. So again, if we're starting to look at potentially like, we'll call it public area phones, or just like hey, there's a phone, like think about it in like a hospital, nurses and such, they have like phones that are just out there, or desk phones or whatever it may be, and someone can walk over, pick it up and dial on it if they need to. Then you got to dial 9 to get out, or whatever it is that you got to do nowadays. There's lots of different ways, of course, around that. So we absolutely can set that up. We could set up other things as well through SIP traffic. So we want to do some, call routings and anything here. We're not going to dive deep into that here. That's not the purpose of this call or of this particular course here. We're not really looking at deep dive into telephony. Okay, that's not what we're doing here. But looking at the functionalities is we can get basically the same thing that we can get before. So we also are allowed audio conferencing, dial-in numbers, so we can have a dial-in. We can do auto attendance and call or hunt groups. We're going to talk about those here in just a little bit. And call queues. Call queues is another factor, and this is starting to become a big deal, and we're talking about call centers. But we'll talk about those here in time. So when we look at PSTN calling. So this is a feature that allows the TeamSoft client to place phones to the PSTN. Okay, so, hey, we have, I want to be able to dial from my device out through the public switch telephone network. I can do that. Okay, I can set that. I can call my cell phone, or I can call somebody else's cell phone. Okay, cool. A lot of things that I can do there. Now, let's just say that we already have existing phones. We have, an old Avaya network or something that we have where we have desktop phones. But again, everyone's working from home, so I can't just take that phone with me. I just set it forwarding to my cell phone, and then I leave it there collecting dust while I'm working from home. That's not necessarily and that's the whole purpose of this, is that we want this to be available to people no matter wherever they work, which is why we're focusing on this here. So what we can do is we can take some of these modern devices here and we can plug them into any network. We can tether them off of our laptops, and we can still have the ability to place calls if we want. So there's a lot we can do with this one here, but let's just say we already have an old Avaya system here and I have a dedicated phone number. Okay, well, we can port those over. We can essentially kind of bring those into, say you have a number that was, whatever number it is, and you dial that. We want that to essentially kind of come over to our Teams client now and to our Teams device. Okay, that's easy. We can do that. We can port those over. Those are all done on the back end. Pretty easy to do. Generally over a weekend, we just port these over from the carrier, whatever it may be. Next, P2P. So P2P stands for peer-to-peer, so there's a big difference between peer-to-peer versus PSTN calling. PSTN calling goes over the phone network. Okay, so this is if I'm calling a cell phone or something like that. But if I'm calling Mary Jane, who's she may be in the other side of the world, but she's on this side, my side of the company, if you will, and I want to have something called a direct dial. Well, I can just go right directly to Teams and call them from there. That's peer-to-peer voice, okay? And that's going to be over IP. Peer-to-peer voice allows me to have the more advanced features of calling. If I just want to have a one-on-one call with somebody, I just call them directly from my Teams client. It uses the same information, same everything. On their end, they get a picture of me calling them, and they can answer it or send me to voicemail or whatever they want to do. So that's cool, but if we have our device that's in front of us here, maybe it's the little hockey puck, or maybe it's over the ear, or whatever it is, we can just call them and talk to them very similar as we could talk to anybody else. But this is going over IP, or essentially the data network. Okay, so we're going over the internet. We're hitting Microsoft's back end. We're using Microsoft's very crazy fast back end network between the two. So we're able to talk to each other. So again, peer-to-peer is different. This is really designed for teams-to-teams calls, where we want to call somebody inside of the organization. That's what that's for. We never ever really called directly to their phone number. That never worked. I'll be honest, I don't even remember really what my actual phone number is at work. I just use Teams for literally everything. So you can do that. And like I said, you can also have it forward or broadcast out. So if somebody calls that number, it can also go to a cell phone and such. So if you're not there at your desk, you can take it from your cell phone. So those are all available too. So let's start talking about some of the features and functions inside of Teams, the voice functionality here. So first one I want to talk about are auto attendance. So auto attendance it's a hierarchy system that allows calls to be automatically routed to the correct location. We've all dealt this. This is, hey, thanks for calling so-and-so. Press 1 for blah, plus 2 for X and Y. And Z. You know, you can understand. You've seen those all before. Now we can be a little bit more granular with these here now, where we can actually do text to speech, where you say, hey, I want to speak to Matt, and it'll say, okay, Matt who? And then it'll say, okay, Matt Alloway, and that's that, and then you get to that person. So you could do things like that, or you can dial by name. Again, you can get super creative there. Okay, and there are so many ways that we can get involved on these here, but auto attendance takes some effort and time to kind of build up. But they can get super complex too, because maybe we want to have some waiting holds or a combination of some of the other things that we're going to be talking about here. Is that, you know, hey, you call somebody and it says, currently our wait time is blah, 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 and we will call you back when we get a minute. You know, those types of things we can do. Or we can go directly to an operator. You know, we've seen these all before. We've all called these and experienced these here. This is where we want to be able to increase the quality of the call. And what I mean by that is the end user's quality. So I'm calling in, I want to have a good quality. You know, not necessarily from the audio quality or the experience that way. What it is that I want to make sure that I get to somebody as quickly as I can so I can resolve my issue as quickly as possible. So 100 ways we can figure that. And we'll look at some of those. Call groups or hunt groups. These are routing systems that allow for a call to be routed to several different recipients at once. So a hunt group here, or we'll just say a call group as it stands, is I have one extension and it gets blasted out to many different people. So in this instance here, let's say I call an auto attendant and it says, I want to talk to sales. So I press 2. Press 2 for sales. 2, when I press 2, goes to a call group. And this call group is lots of different people. And it'll ring 10 phones at one point in time. And any one of those salespeople could pick up the phone and start doing what they need to do with it. That's cool. We also have the ability to do hunt groups where it can start off with one person and they don't answer there, and we move to the next person and we can essentially hunt till somebody picks it up. So that's the purpose of hunt groups and everything. We've again seen these before. These happen in the back end. We don't really know that this is happening while we're working with them, of course. But call groups and hunt groups are important as well. And they're very useful for an organization that relies on phone calls. Then we have call queues. Call queues here are they're newer to Teams here. These are new functions and features being added into call queues all the time here. But this one is really around a help desk potentially, or it could be a call center scenario here where incoming calls are queued and routed to the next available agent. So these really kind of work in like a, we'll call it, you think of like a ball coming in, it gets routed over and it basically sits there till somebody can pick it up. Now, these queues here are, you know, hey, we have some on hold music, or we have some other options that are available to us, like current call or current wait time is 25 minutes. You can wait on the phone or press 1 and we will call you back when an agent connects you. Now, there's some pretty advanced stuff that's going on in the back end there, but you can do that, and that's another convenient option for you. So again, these are commonly used in customer service and call centers. So the cool thing about this here is that the agents, okay, so the people that are there as they're working with people, they'll be able to pick it up and they can do their thing, but they can use their presence inside of Teams to mark themselves as ready or not. If they're available, that's fine. Or, hey, I need to go use the restroom. I'm just going to mark myself as away, or essentially do not disturb, and I'm going to go use the restroom, come back. During the time where I'm away or do not disturb, I will not get any calls placed to me. It'll only be if I'm essentially on the ready, green, ready to go, where agents come in and whatever. If I'm in the middle of a call, it won't route any to me either. It's going to basically just wait for it to be done. So there's a lot of logic built into it, and we can use our presence directly to it. So again, let's just say, hey, I'm on vacation. I put an out of office or something like that. I will not get any calls routed to me. Or again, there's a lot of different things they can do, but it's the presence inside of Teams that really is essentially saying, hey, I'm here or I'm not here and I'm ready to take calls. Now we have the ability to record calls. We have the ability, for, hey, this call is recorded for quality assurance purposes. We've seen that before too. We can absolutely do that. We can do some spot checks. We can also do manager drop-ins as well, where a manager just kind of picks up a couple of calls and listens in on them just to see. It's essentially just a one-way communication there, so they can just kind of pick up and see and what's going on with it and just listen on to a couple as well. Just all for quality experience for the customers or the people calling in there. All right, so we're going to jump over into the lab here. We're going to play around with it. Now, you're going to be able to do a lot with this here, but we'll still play around with the lab here, and I'll show you some of the things that you can do, and I'll definitely demonstrate some things that you can do here. So we'll work through all of that here, but that's it for this particular lecture here. So thank you for your time, and we're going to go ahead and jump over into the lab. So thank you again.